Yaskawa.
Hi, I'm Stephen Peterson, and I'm one of the product training engineers here at Yaskawa America Incorporated. In this e-learning module, we'll be discussing the features and benefits of the D1000 active front end. The D1000 is Yaskawa's high power factor converter with power regeneration capabilities. To understand what the D1000 is and when it is practical to use, let's start with a brief lesson on regenerative energy, commonly called regen for short. Regenerative energy is defined as the electrical energy created as a result of a motor shaft turning faster than the drive's output frequency. This is because an overhauled motor acts as a generator. A simple example would be a vibratory table. The rapid up-down motion of the table is a cyclic load and will cause regen to flow back into the drive. So why do we care if overhauled motors regenerate energy and put it back into the drive? What's the big problem? Well, let's look at a common application to further understand regen. Pretend that we have a downhill conveyor with a drive running the conveyor. In this application, there's a lot of regenerative energy due to gravity. The drive will command the motor to run at a certain speed and direction. This is the speed reference. Because of the weight of the product on the conveyor and the force of the gravity, the conveyor will naturally want to accelerate downhill without needing the drive to perform any work. When the conveyor starts to run faster due to gravity and the load, the motor must hold back the load to maintain the commanded reference. This is called the holdback torque. During this time, the drive is being overhauled and is in constant regen. While in regen, the energy goes back into the drive and charges up the DC bus. The rectification circuit on the front end of a drive is a one-way street. The DC bus voltage has nowhere else to go. The DC bus capacitors can only store so much voltage. If that voltage level keeps rising up, an overvoltage fault will occur. A downhill conveyor that must hold back a load is just one example. There are quite a few other examples that regen may exist on. This includes, but is not limited to, applications with overhauled loads, applications with rapid deceleration, cyclic loads, and also high inertia loads. More specific applications will also be brought up later in this presentation. So what are the available solutions commonly used to handle regenerative energy? Most commonly, when dealing with low amounts of regen, dynamic braking is used. Dynamic braking will consist of a dynamic braking transistor, also referred to as a chopper, and a dynamic braking resistor. When the DC bus level rises too high, the transistor closes, allowing the excess bus voltage to bleed off onto the resistor. This method is primarily chosen due to the relatively low cost and simplicity in the wiring and installation. However, with dynamic braking, there is no energy savings. All of the energy dumped onto the resistor is burned off and wasted as heat. Additionally, when an application calls for a higher duty cycle due to increased regen, the size of the braking transistor and resistor will get larger and could multiply. Braking modules are run in parallel. This means that it will result in a larger footprint and more wiring. Dynamic braking is commonly used in applications requiring a duty cycle of 10% or less, but it is not limited to that number. On applications with higher regen present, a 6-level regen converter can be integrated. A 6-level regen converter connects to the drive's DC bus and into the 3-phase power utility. Excess bus voltage is directed into the regen converter, which is wired in parallel to the drive. The regen converter then takes this energy and pushes it back onto the utility line. A 6-level regen converter will provide energy savings since we are putting the energy back onto the line. This is a benefit over dynamic braking where the energy is simply wasted. On the contrary, there is no harmonic mitigation provided on a system like this. Additionally, the wiring can be extensive and somewhat complex. A regen converter can be sized to handle up to 100% continuous energy dissipation. Enter Yaskawa's new D1000. The D1000 is the energy-saving solution for any application with regen energy present and also has many other benefits on top of that. The D1000 will eliminate overvoltage trips that are caused by regenerative energy. This is due to the unit's ability to continuously convert 100% regenerative energy and to apply it back to the supply source. When 100% of an application's regen can be put back onto the line, a significant energy savings and a large cost savings will reduce that monthly electric bill. The D1000 also features a high power factor and low harmonics. So you may be asking yourself, what makes the D1000 so great? First of all, it's green. No, not the actual color of the unit, but the functionality of it when integrated with an application. In more ways than one, buying a D1000 is just like putting money in the bank. Any regenerative energy is tossed back onto the line and is considered energy saved and can be used elsewhere in the plant. The D1000 will output a clean, pulse-width modulated sine wave. This PWM waveform and unity power factor result in low harmonics. The D1000 is the solution to mitigate any harmonics. The D1000 is wired in series between the power supply and the drive. This puts the D1000 at the front end of your VFDs and amplifiers, eliminating harmonics produced from the nonlinear loads. The resulting mitigated current distortion on the utility from using the D1000 allows for smaller power supplies, smaller cables, and decreased cost of operation. For a more in-depth explanation of harmonics, check out our ELM. It is titled elm.afd.07.harmonics. The D1000 will be released for both 200 volt and 400 volt supplies. The 200 volt class is rated for 200 to 240 volts AC. The ranges vary from 5 kilowatts up to 130 kilowatts. A maximum voltage deviance of minus 15% and plus 10% is allowed. The 400 volt class allows for a 380 volt input on the low end and a 480 volt maximum. This class features a broad spectrum in capacities varying from 5 kilowatts all the way up to 630 kilowatts. The same minus 15% to plus 10% voltage tolerance exists. Yaskawa has always tried to keep consistency at the forefront, whether it be consistency in quality, product lineups, or something as simple as the model number. For those familiar with Yaskawa's 1000 series lineup, this model number breakdown should be nothing new. The D will naturally designate that the unit is a D1000. Following that, there will be a regen code, the voltage class, and the specification. In addition to voltage class, one of the most important designators is the rated output capacity. This value is in kilowatts, and it designates how much power the specific D1000 can deliver. Bear in mind that this differs from our drives, which are rated for current. The last three designators will determine the chassis type, any added environmental specs, and the revision of the unit. The D1000 is compatible with all of Yaskawa's current industrial drives and motion amplifiers. This includes the A1000, V1000, J1000, the L1000, G7, and also the Sigma 5 product. Sizing is as simple as matching the drive's power rating to the D1000's power rating. For instance, if a single 480 volt 45 kilowatt drive is required to run an application, then the D1000 must be rated to at least 45 kilowatts. In this case, the 400 volt class jumps from 40 kilowatts up to 60 kilowatts. So a 60 kilowatt D1000 is the proper unit to use. There is also an easy selection table available for use in the product catalog. In cases when multiple drives or amplifiers are being used, the D1000 can be sized to be utilized as a common power supply for all of the load. Also, you can save and recycle the regen energy across all of these loads to take full advantage of the D1000's capabilities. Sizing is as simple as adding the total capacity of all drives or amplifiers being used, and sizing the D1000 so that the power can handle the sum of the cumulative power. Installation time and wiring for the D1000 is kept to a minimum. To save time and to take the guesswork out of picking the necessary additional components, Yaskawa eases your mind by selling the D1000 as a complete package. This includes the D1000 unit, a PWM filter module, and also an AC input reactor. As you can see, Yaskawa makes selecting a D1000 and pairing it with the correct components a breeze. The D1000 takes the AC line input and outputs DC power to the drive. Main circuit connections are left as simple and as straightforward as possible. AC line input is wired through the customer's installed protection, such as a breaker or fusing, into the harmonic filter module. The input reactor is then wired in series between the filter module and the D1000. Leads are ran from the harmonic filter module to the voltage detection inputs. And lastly, the two DC lines to the drive must be connected to the output. Despite the simplicity and the minimal amount of wiring required to set up the D1000, there is plenty of I/O built right into the D1000 to meet a wide variety of needs. Standard on all D1000s are 8 programmable, optically isolated digital inputs. 3 analog inputs are available, with all 3 being capable of processing a 0 to 10 volt input and 1 having the ability to process a 4 to 20 milliamp signal on top of that. There is 1 designated fault contact operating on a Form C relay, and also 3 additional programmable contacts. 2 programmable analog output monitors, which can source 0 to 10 or 4 to 20 milliamps, are also at your disposal. All of this robustness that is the D1000's I/O is located on a removable terminal card. The removable terminal card is beneficial as it automatically backs up any programming changes made to the unit. In addition to all the programming being backed up, unit replacement will fly by in no time, minimizing application downtime since all of the wiring does not need to be relanded. For example, if a D1000 unit must be replaced, simply remove the terminal card, dismount the old D1000, and mount the new D1000. All of the application's wiring and programming is on the original terminal card. All you need to do is plug in the terminal card, load the backup, and you will be up and running. All D1000s come standard from the factory with an IP00/IP20 type open chassis. NEMA 1 kits are available for all sizes to meet your needs. Here at Yaskawa, we understand how important and costly space is. The D1000 design features various size and installation reductions, resulting in less space needed and a quicker installation time. To sweeten the deal, the D1000 can be mounted as close as 2 mm side by side, next to the drives it is supplying power to. This is virtually touching and will maximize the limited space you may have. Be sure to reference the tech manual for further information about a side-by-side mounting setup. Ease of programming is a critical benefit on all Yaskawa products. The D1000 is no exception. Stress-free programming is provided since all parameters are organized into groups. This makes finding what you need simple and efficient. The D1000 features a full text keypad. The standard display is an illuminated LCD type, making it easy to read and interpret. The keypad offers parameter backup capability with memory built right into the keypad. Navigation is intuitive and works the same way as Yaskawa's other 1000 series keypads. There is also 2 available soft keys which can be programmed to display or operate based on your needs. There are 8 available languages that the keypad can display. The keypad can be mounted remotely without hesitation since it is removable and can run off a standard straight-through Ethernet cable. Additionally, complete remote mounting kits are available through Yaskawa. This makes it easy to integrate the D1000 into any existing enclosure. To accelerate setup and programming further, Yaskawa's PC tool, DriveWizard Industrial, can connect to the D1000 with a standard type A to B USB cable. The software's interface is streamlined and easy to use. The software features the ability to create and save parameter files without the need to be connected to the unit itself. Programming from the D1000 can be backed up for storage as a number of different file types for personal reference or for sharing and sending to others. Live parameter editing can be performed, as well as graphic trending for up to 6 monitors at a time. The D1000 features a monitor menu. This menu contains a wealth of monitors to make operation and troubleshooting easy. The basic operation status monitors include input and output terminal status, along with analog input monitors. Since the D1000 is a converter unit, there are many critical monitors for power supply voltage levels, DC bus voltage references, feedback, and current values. Additionally, a power factor monitor will display the current power factor of the converter at any given time. There are a number of special monitors that are available based on the main reason why the D1000 was developed, and that reason is energy savings. Electrical power consumed can be viewed in kilowatts along with the regenerative energy that is produced from the unit. The D1000 features the ability to program your current power unit price right into the parameters. By doing this, you could take advantage of additional monitors that calculate the money spent to consume electrical power and also the money that's saved based on the regenerative power created. Should a fault condition ever occur on the D1000, we've got you covered. The unit can be set up to automatically restart on a fault if desired. There are also 2 monitor groups solely dedicated to helping the operator troubleshoot any fault. The U2 monitor group will list what occurred at the most recent fault. Think of this like a snapshot that was taken during a fault to list all the monitors that you will need to look at to make an analysis. Secondly, the U3 fault history group will list up to 10 of the most recent faults. This is great for tracking previous faults and for checking patterns. The D1000's internal components are tied to yet another set of monitors. The U4 Performance Life monitors display what percentage of the estimated life of each component has been used. Once a certain level is reached, the keypad will give you a friendly reminder that preventative maintenance is recommended for the aging component. Yaskawa, reliability, and quality all go together hand in hand. The D1000's components, such as the fans, capacitors, and relays, are rated for a 10-year lifespan. The D1000 unit also struts an industry-leading 28 years mean time between failure. Meeting the correct standard is always a necessity for panel builders and equipment users. The D1000 is UL recognized for both Canada and the US and carries the CSA mark. The D1000 will also be appropriate for use throughout Europe since it meets CE requirements. The D1000 also uses all RoHS compliant materials. The D1000, as previously mentioned, is able to adapt to a wide variety of different applications. But, to make it answer to all applications without bloating the unit with features, the D1000 offers a deep list of optional add-ons. The D1000 has 3 serial ports. Each is rated at 1 megabit per second. These 3 option ports are easy to access, making field installations possible. An analog output option adds 2 additional analog signals to the D1000. These supplementary outputs can be used for metering or monitoring the majority of the unit's monitors. An available digital output card provides 8 additional digital outputs for the monitoring of the status outputs. The 24-volt control power unit option provides board-level component voltages for the D1000 when an external 24-volt supply is present. The Y-Stick is Yaskawa's USB copy unit. This device can be used as a USB pass-through to connect the unit to a computer, or can be used to read, copy, and verify a parameter set. The D1000 features many options as far as network communication protocols. These options will enable the D1000 to connect and interface to an industrial network for control and/or monitoring. The available options are DeviceNet, Profibus DP, Ethernet IP, Profinet, Modbus TCP/IP, and the unit's native protocol, Modbus RTU, which does not require an option card. To review, there are some huge key characteristics of the D1000 that will prove to be beneficial for a wide variety of applications. These benefits include a unity power factor, low power supply harmonics which result in lower losses due to heat caused by current harmonic distortion, power regeneration capabilities, eliminating the need for wasteful dynamic braking systems, and the ability to source power from one D1000 to multiple drives or amplifiers, resulting in minimal wiring and a small footprint. The D1000 fits in perfectly with conveyance equipment, including conveyors, elevators, and escalators. As far as the manufacturing field, the D1000 can be applicable to textile, presses, centrifuges and decanters, mixers, winders and rewinders, web applications, and also machine tools. The D1000 can even be integrated with your HVAC or building automation equipment. This includes fans, pumps, compressors, cooling towers, and also air conditioning units. Well, we've come to the end of this training program, but it is definitely not the end of our commitment to make Yaskawa drive and motion products the best in the industry. To us, quality means doing everything to make our customers, partners, and employees' experience a great one. We commit to that. We make it happen. We can, because to us, it's personal.